Hey everyone, welcome to another quick tip. Today I'm really excited to talk about super smoothers. Now super smoothers are a way to reduce noise in your data, and we're going to use COVID-19 data today. There's a lot of noise and reporting inconsistencies in different countries and different regions around the world. So how do we remove those reporting inconsistencies and show a true epidemic curve? The way that works is if you look here at this epidemic curve, you'll see that this blue line is a 3-day moving average. This red line is currently set as a 12-day moving average. This is what we showed last time with moving averages. The blue line is really hugging that data very closely. You see it very choppy there. So it's not really removing enough of the bias in the reporting. I'm seeing moving averages used a lot. But they're not really the best method here. You can kind of increase the moving average here at 12 days. That red line is a little more smoothed out, but any moving average is going to be shifted over by half of the moving average amount. So if I have a 12-day moving average, you'll see this line is actually shifted over by 6 data points. Now the black line that we have here is a super smoother. So this is a better true epidemic curve. And this, you'll see, doesn't hug that data that close. It's not overfitting. It's really representing the actual epidemic, how it's increasing and decreasing. You know, when we see these dips, again, it's probably reporting issues, not actually people that have gotten less cases or more cases, things like that. Now I'm going to start by showing how the smoother works. If you just want to know how do I put this in my DXP, you don't really want to know how it works, you can skip to the end of the video where I'll show how you can use the data function and drop that in. So the core of our methodology today is going to be a super smoother, and this is using Friedman super smoother. This is using the SUP-SMU function that's in R that comes right out of the box, and this is going to take an input for an X value and a Y value. You can specify a span if you want. You can choose different parameters for smoothing. I'm going to explain here that what it's going to do is actually create 3 running line smoothers. One that is 0.5 times the number of data points n, and that's going to be a local neighborhood around the point that you want to predict. And it's going to be symmetrical, so it's going to distribute those points on the left and the right side of the predicted point. It's also going to do another running line smoother for 0.2 times n, 0.05 times n. Then it's going to actually take those predicted values, it's going to do another round of smoothing on that, and then it's going to do a linear interpolation across those remaining values. So let's take a look at how this actually works. So here in R, I've taken some case data, so I've put this in R. Let's take a view here. This is some case data for United States, and a key thing with the super smoother is you want your data to be sorted. So this is time series, you want it sorted by time, and you don't want to have any duplicates in there. You want to remove any duplicates before you get started. So this is the data, and we're going to be smoothing on the date and the new cases. Now the super smoother is bivariate, so it uses 2 variables. And this is going to be doing a localized linear regression. So to take a look, I've gone ahead and created an X and Y here. So X is my dates and Y is my new cases. To plot this, the raw values here, this is the raw data. So the first thing the smoother is going to do is do a span that's 0.5. Now you can specify again the spans right here or just leave it as is, and that's going to be a super smooth method. So the first thing it'll do for 0.5 is if I wanted to predict a point that was around here in the X, then it's going to take half of the points, so about that much, and it's going to do a least squares fit, and so that line might look like this. And then let's say, you know, we'll move on and we'll maybe do something here. It's gonna go through every one of these X values, and maybe this line is here, and you know, as it goes through, maybe half the points are here. It'll, if it doesn't, there's not enough points on the right, it will just kind of truncate that out. But now this least fit line is there, and it's going to put all of these together. So as an example of how this looks with different spans, I'm going to go ahead and execute this whole thing, and we can see here the raw data. Using the 0.5 span, you can see that this is so smooth that it's just, you know, it's a very broad stroke here. When you go to 0.2 on span, you'll see this is a little more defined here, and you see it's kind of pulling in more of the curve on this epidemic. But it still has some kind of you know, roughness over here, and this might not be actually specific enough. You can bring it then to a 0.05 span, and this is super detailed. This is really hugging that data, but potentially overfit on that data. For this narrower span, it's going to take a smaller neighborhood. So on my raw data, let's say I was trying to predict around here, it might only take these values and do a line like that. For this, it might only take these values, do a line like that. Same thing, kind of going on only with the more local neighborhood. And that's why you're getting this actually kind of fitting that curve, again, potentially overfitting, but hugging your raw data a little more closely. So now let me go ahead and do this with a actual full super smoother. So now when I run this, you'll see this is the Friedman super smoother, and this is cross-validated. What this just did was it took this 0.5 span, and so for each of these points, let's say each of these x values, it did, okay, this is maybe where the 0.5 is. Maybe 0.2 was just under that here. Maybe 0.05 was under that here. On the next value, the next when it increments over, maybe 0.5 was over here, maybe 0.2 was up here, maybe 0.05 was down here. So we now have a new set of predicted points. So these 3 points all construct the original 3 lines from the 3 spans that I talked about. It's then going to take a 0.2 times n, and it's going to do another smoother on this. So it's going to take the local neighborhood over 0.2 of the data, 20% of the data, and it's going to start actually fitting that way. So individual local spans, and then it's going to take those predicted values, and then it's going to run the smoother again. It's going to super smooth run it again. Now, after that, if there's any remaining x values that don't have a y value, it's going to do some linear interpolation as well to give you a completely smooth curve and a complete curve. So here in Spotfire, we have our moving averages that we were talking about earlier, and I have a super smoother data function here. I've included this in the Spotfire Starter DXP community page, so you can download this for yourself. I'll put a link to that in the video description. What this does is it actually goes through and it's going to window the data by each country. You're going to have a different smooth value for each country rather than doing them all at once. And it's going to take an input, so you'll give it an input as a date, you'll give it an input as whatever value you want to smooth, and then it's going to spit out an output. The output is going to be the smooth value as well as the derivative of that smooth curve throughout it. So if you want to get a rate change. And here in Spotfire, the magic is all happening right here with the super smooth method right there, the super smooth function. If you go down, you'll see there's some data preparation steps that get the data ready for each of those windows by the country. It sets certain names, and then there's the actual generating stats function, which goes through and creates our smooth values. Now, as I go down here, you'll see that it's going to generate an output, and we've set this up to take column inputs and spit out column outputs. So as I run this, I'll show the parameters. So the identifiers, here is what I want to window by. So with this data, I'm going to do it on the world countries data, and I want to window it by the country ISO 3. That's a unique identifier for each country. And then the values I want to smooth, I can then select if I want to do new cases, as I just discussed in R, but I can also select other values I want to smooth, like the overall cases, the deaths if I want. I can bring in whatever columns I want to smooth, and I'll hit OK there. And then I just need to bring the date column. So here I'll go to column and I'll select date. Now the output is going to be a column output, and we want to write these columns to our existing world countries data table that has all of our cases and deaths and recoveries in here. So I just have this set to that data table, and I'll hit OK and I'll close, and you can see that this is running pretty quickly. It shouldn't take too long. So there, that already completed. And now when I go into my data canvas, we'll be able to see in the final world countries, it generated all of these columns. So as I go over here, you'll see it has the new deaths value, and that is super smooth. It has a derivative of that. It has the actual deaths, cumulative deaths smooth. As I continue to go down, we have new cases smooth, and that's what we're going to work with. So these are now the smooth curves. So I'll just throw this into my actual chart here. And now you can see that curve, that black line is a super smooth curve. And you can go through and you can see these really interesting epidemic curves here. Let me turn off the other curves. And now we're seeing just that smooth value. So if I go down to, let's say, Germany, and we take a look at Germany, we can see Germany's epidemic curve. It's giving us a good value there. If we look at maybe Iran, which has been a little back and forth, you can see Iran moving like that. And there's Iran showing that it's now starting to uptick. So these give you much cleaner epidemic curves. If you like this video, make sure you subscribe to the channel. We're going to continue putting out new tips, and we hope you continue to join us. Thanks for joining us today, and we'll see you next time.